Great. Thanks for that kind introduction. Good morning, everyone. Good morning. Hey, that's a better welcome. Thank you. Uh, so, guys, I am from American Express. I have been leading AI and ML initiatives at the company. Most recently, I have been working on this amazing technology, GenAI, to transform document AI space, like how a company like American Express would use documents in their underwriting and other decisioning, and how GenAI can make many of these processes simplified, more robust, and accurate. So before we jump into, I would like to give you an overview of what our company is. I think American Express being a 175-year-old organization, I think innovation is in our DNA. We have been embracing new technologies to create new products, services, to enhance the customer experience and meet their ever-evolving requirements while keeping the true promise of our brand in trust, service, and security. We were the first few financial services which started using machine learning in 2010 to protect our card members from fraud. And over the years, with the responsible use of AI, we have been providing personalized experience to our card members, as well as automating a lot of historically time-consuming activities and processes. With advancement in Gen AI, I think that is also something which excites us a lot. And unlike other technologies, we are also very active in embracing the generative AI technologies. At American Express, we have been on this journey of Gen AI for more than 2 years now, and over 100+ use cases to improve the customer experiences, improve the productivity of our colleagues so that they could add or contribute to the more value-added services, and more importantly, protecting the systems and data that we have. As our brand evolved, our services, our products evolved with our history, I think I will also tell you some examples how Gen AI is transforming how we service our customers today. I'll take few examples. The one is the Travel Counselor Assist. It's a product that uses Gen AI to come up with recommendations or travel plans to support our travel counselors who service our premium Centurion and Platinum card members. This is a fully rolled out service that supports our travel counselors across the globe in 19+ markets who are servicing all our Centurion and Platinum card holders. Another example I would like to mention here is on Code Assist. American Express having a lot of tech stack, right? We are using Gen AI for our software engineers to assist them with code generators as well as completion. We have recently introduced a chat interface there and are seeing very early results of increased productivity. Soon there will be an integration with the GitHub Copilot so that the documentations for the API as well as the code summaries could be auto-generated, which will save a lot of efforts and increase the productivity of our card members. With our extensive experience leveraging traditional AI over the years and leveraging the data responsibly, I think we were quick enough to jump into Gen AI. But our approach with generative AI has been test and learn, iterative. It's always grounded in metrics and objectives. And this has helped us evolve our implementation over the time to learn and adapt and make it more reliable and robust. With that, I'll move on to the core of today's topic, which is how Gen AI is transforming document understanding and intelligence for American Express. Like many organizations which are on the journey of this digital transformation or data-driven strategies, I think with the advancements of AI, this has fueled a lot of automation, but primarily one of the challenges that has been persistent over the years that most of this was restricted to the structured data, given it is easy to store, easy to handle. But as all of us would agree, a lot of enterprise data flows through documents, contracts, policies, invoices, banks, financials in a financial services industries, right? So the digital transformation journey of any enterprise would rely how effectively they can leverage this unstructured data, and specifically today, how they can use the data in documents, process it, and understand, get insights to make their decisions much faster, improve customer experience. That's what we are going to see today. Before we jump into it, right, I was preparing for this talk today, and I thought I'll just look for a formal definition of document understanding, and I found one, which states about document understanding refers to algorithms and techniques that are applied to images of documents to obtain computer-readable description from pixel data. I think that's okay, but in today's context, I would say that the objective of document understanding is to extract information or intended information from documents as humans would do. I think one of the keyword here is intended information. That's very critical in this era of unstructured documents where you could get lost in the volume of the data. So what is the intended information that I need to extract for a specific task at hand? While document understanding could have a broad spectrum of what it could achieve, but with proper understanding, there are few examples of the tasks that I listed here that can be done. Simply like a simple task like document classification. To understand what kind of document will help you decide the downstream treatment and how it is being used in the downstream processes. Document verification. I think this is a slightly unexplored area, but when the decisions are based on the information from documents, it becomes very critical to make sure that the information that I have on the documents is authentic, has not been modified or tampered with. The remaining two parts, the information extraction, I believe this is one of the most explored area where you would try to process key information from the documents, process tabular data, or free-form text, charts, whatnot. And the final, which is one of the most involved tasks, is how do you extract intelligence out of this data. Some of the examples in this domain could be visual document question answering. While this is the most involved process, it's also the most rewarding one. We'll get into it in some time. Now we understand what are the document understanding tasks. Let's also have a quick preview of what kind of documents are available across the enterprise. And to simplify this, these are not exhaustive, but I have divided them into a broad spectrum, moving from left to right. On the left, you see structured documents, which you could even say that do not change over time. These are fixed form documents like your tax forms, any medical insurance forms that you're working, and they are easy to process. While on the extreme right-hand side, these are the unstructured documents, which are the most complicated one and are dominating in reality, like the contracts, financial statements, which are available in free-form text, could have tabular data, could have images, charts, and becomes very difficult to process. And in between is what I call a semi-structured document, which have a fixed template. Let's take an example of bank statement, right? You would imagine a bank statement would have some bank entities, transaction descriptions, and so. But why I call them a semi-structured? While you could imagine a layout of a bank statement, but if you look at bank statement across different banks, they may vary slightly, right? So it's not a fixed form, but yeah, somewhat easy to manage. And now I motivated the use of document AI, what documents are there, but why are we talking about it? Why is it so special that we have to give special emphasis to this, right? So documents are not just free only text, right? While a lot of research has happened on processing text, NLP, and so on and so forth, documents are not free only text. They are multi-modal entities. They have a lot of infographics, they have tabular data, they have text. So it's a multi-modal representation of data, which makes it more complicated, given a spatial alignment, like where the information is present, whether it's sequential, whether it's top-down, would make the meaning of the information different. Even for global enterprises, right, while we have seen that the intra-class variations are itself so daunting, when we talked about global enterprises, as we move across geographies, the language, the type of data, the type of documents that are being used for the same process across geographies even make this problem more challenging. And it's not that document understanding or the visual document understanding is an unexplored area. There has been a lot of research that has gone over the decades. But if we talk about a generalizing approach that can solve for all the problems at hand, I think it's still missing. If we try to explore what has happened, like people have tried to come up approaches to process the tabular data in the documents. There have been, if I simplify, there have been approaches where they would take a two-step approach. First, identify where the table is, then try to recognize the table structure recognition. With advancement in deep learning, transformers, I think it has become much smarter that both these objectives can be solved together. If we talk about the second problem, which is like the key or the document digitization, this is the most explored area in document AI. And it's much mature. The idea is like any kind of documents, banks, financials, forms, you want to extract the entities as key value pairs. The third is a more interesting problem. It's more advanced in documents. You want to understand the equations, mathematical forms. There have also been research on how you could interpret chart data, right? And if as subtasks, like you could process chart as your input, and with some of the pipeline going there, you could convert your unstructured pictorial representation of data into a simplified CSV form, which would be representing the data used to prepare that chart. I think you could imagine in organizations where PPTs, charts are the way of communicating, how a document AI system could just convert all that data for a systematic processing. And finally, we talked about the most involved job, which was visual question answering. I think there has been approaches. It is the effort to mimic human behavior. Given an image, if you ask a human about the questions, I think they can interpret that well and answer it. But for a machine to do that, it's an interplay of text vision as well as the reasoning on these two modalities that makes it challenging. Just to support why this is a very important area, there has been a lot of challenges, data sets that have come across PubliNet, DocLiNet, right, which talks about different document components coming from different areas, medical journals, patent documents, just to promote more thorough understanding of this document structure. One of the recent data set that has come is DocBank, which overcomes the limitations of the existing two data sets, because the other two data sets were primarily tuned for computer vision tasks, right? Because they had document images and annotations on top of the large semantic document components, which limit the application of NLP-based techniques because we did not have the token-level annotations. But with this DocBank dataset, I think now you could even include your text into the image and the spatial resolution. And I think just to highlight one of the trends here, as we started with simple text or the image-based encoding, but now the trends are that how you could imagine all these multi-modals come and play together to give you that deeper level of insights. Earlier, it started with simple rule-based techniques, which worked for like structured documents. But over the journey, NLP-based approaches, deep learning-based approaches, and transformers have come into the way, and they have solved this problem to an extent. You would see a lot of products, a lot of AI going in understanding those documents. Just to a takeaway that you should have today, right? How this space has evolved. So as I mentioned, we started on the left-hand side only with simple text-based approaches. How can we build NLP models that could tag what the other entities could be? It worked well, but as the documents are complex, right, it did not suffice. So we started moving to layout and the text, right? So how you could also use the bounding box information, how the information is spatially positioned, that also became important in some of the recent models, but it was still not there till the time there came transformers, which could merge all these modalities, text, layout, as well as image, to learn deep dependencies and cross-modal interactions between all these data. And that's where today the traditional state-of-the-art layout LM V2 and V3 models are, which could solve to an extent very complex tasks for different document understanding. But what was the challenge there, right? We were doing good with the traditional machine learning algorithms. Transformers were doing great. But where it all hit us hard was You need to have a lot of annotated data to build models for specific document types, specific tasks, specific geography, which is not scalable, like for a global enterprise. Even if you build on as much data, there would always be corner cases, and you would end up writing more custom rules to account for those corner cases. How do you solve for the problem of generalization? There are many dependencies, OCRs, can even include more errors in your solution. And complex document, like if you have trained a model in production, a bank changes a template, or you get a new document, your system goes for a toss. While GenAI provides a robust solution to all these approaches, they are more generalizable, require a lot of less annotated data. They are robust to any template layout changes. And moreover, like GenAI comes with a lot of contextual understanding from the large corpus of data it has been trained on that allows any GenAI model to simplify any task that we have been doing. I'll give you a few examples, like what has been the landscape in this area. Doc LLM was one of the most prominent breakthrough, which solved this problem of understanding any representation from the document. They came up with 4 simple innovations. One was, rather than using complex image encodings, how can we use the textual data as well as the spatial bounding boxes just to represent the data and its information. They also came up with this tangled spatial attention, the idea being where many transformers just combine the spatial and layout embeddings. They treated it separately so that they could learn the cross-model interaction. Many in value trace, transformers, and other stuff, our pre-training task is how can I predict the next token. But you could imagine in a document which is like ill-formed, it's not flowing sequentially, information is vertically top-down, that kind of approach will not work. So that's where they came up with infilling pre-training task where not just the next token, can you also make predictions about what would be the previous token, which works very well for any unstructured or ill-formed document. And finally, like instruction tuning has been a great approach where you could give small instruction fine-tuned data set on your specific domains to fine-tune those LLMs for your job. And this has been a very transformative approach, outperformed all the previous approaches and many complicated multi-modals LLMs as well on the document AI task. I'll skip this one, but I'll talk about this table GPT. We would all agree, like a lot of documents that we see, a lot of presentations that we see have some kind of tabular data, reporting metrics, because tables are like a very precise way of communicating a lot of information in a very precise way. And it becomes like when you talk about understanding those documents, how do you process these tables in a more effective and automated way. And why tables are different, primarily text is like a one-dimensional data you could read sequentially. But when you talk about tabular data, it's a two-dimensional data. You have rows and columns. And traditionally, LLMs are not trained for those. They are trained on large corpus of data. So they lack in that understanding. And one of the simple approaches that was proposed by Microsoft here was, why can't we come up with instruction fine-tuning for LLMs rather than giving it just a response and prompt and the response? Why can't I do it for a table where I give the table image, my question or the prompt, and the response? So it's a triplet rather than a tuple in traditional instruction fine-tuning, and that made wonders, right? So if you see in the left examples, like the LLMs are making mistakes whenever we talk about something which is vertically aligned, while reading horizontally, they are very good, 92 or more than 90% performance. And that's where came the power of table transformer, where just giving few examples of how LLM should interpret a tabular data, it made wonders for interpreting and understanding the tables. So given this, right, so understanding key value information, tabular data are one of the key information that you could extract for all your downstream processing from the documents. With that, I leave up with you guys with some of the existing or emerging topics. If you guys are excited about how documents can be used in your area, your enterprises, I think one of the approaches how you could leverage multi-modal LLMs, right? Given we have talked about documents being a multi-modality, how you could make it the interplay of text, visual, and the layout play for you. I think in the previous talk, we also talked about agentic agents, right? So while the effort has been focused on extracting information, these agents, LLM agents, can be trained to do a lot of jobs like underwriting, approving the documents, and all that stuff, right? These can be trained as separate agents. RAG, prompt engineering, is one of the key initiatives that you could solve a very complex task by using simple domain-specific information. So maybe I'll just stop here, and happy to talk more and take any questions how you would like to use this in your enterprise and how we are using it in our problems. Thank you.